Welcome to the Software People Stories. I'm Shiv.
I'm Chitra.
And I'm Gayatri.
We bring you interesting, untold stories of people
Associated with the creation
Or consumption of software-based solutions.
You'll hear stories of what worked,
and sometimes what didn't,
you will also hear very personal experiences.
and insights that would trigger your thoughts
And inspire you to do even greater things.
A journey of thousands of kilometers starts with finding a book in the library of one of India's premier research institutes. Thus began Usha's quest. Usha is a consultant at PM Power Consulting. From becoming self-reliant and braving any situation that comes her way is how I'd summarize my conversation with her. Talking to what I call a scientific mind is like tapping into mini treasure troves of experience. From scientific programming to setting up performance testing labs, being responsible for what one builds and sells, and having your eyes open wide when you test and integrate a product with your customer, doing usability testing right beside you. 3+ decades of Usha stories are peppered with delightful experiences. Listen on.
Good morning, Usha. A very warm welcome to you to the Software People Stories podcast. It's nice to finally have a conversation with a PM Parian after a very long time. Welcome to our podcast.
Thank you, Chitra. Happy to be here.
So, Usha, as is tradition with our podcast, we ask our guest to introduce themselves. How would you like to do that for our listeners today?
Okay. My name is Usha. I am from the south end of this country. I spent most of my working life in Bangalore. I moved here after my graduation and I spent most of my life here in Bangalore.
So, Usha, was computer science or a career in software engineering by choice, or how did that happen? How did you choose to take up science or studying computer science, if you did, and prepare yourself for a career in software?
Interestingly enough, I prepared myself for a career in science, I should say. So I did my post-graduation in physics. I don't have a computer science educational background. So in fact, the first computer I saw was at my workplace in Raman Institute, Bangalore. So I worked in the institute for nearly 10 years. I worked there in the computer department and did various things. So that was my first exposure to computers and computing. So till that time, I had not physically seen a computer.
That's very interesting. So what was your work at the Raman Institute like?
I would say that it was challenging. I remember my first day in the institute. So I met the professor who was my boss. He pointed me to a book in the library. He said, go read it and then try it on the Bax computer out here. So they gave me a username and password. So basically I had to go to the library, do a lot of self-learning, understand what computers are used for, understand the basics of logic. And that is where I started. So when I got stuck, there were people to help me. But a lot of things that I had to do was self-effort. It is a research institute, so people expected you to do your own research.
That must have been quite challenging. So how did you actually begin to pick up the threads of programming and logic and then actually apply them to programs? And I'm making an assumption here that you may have had to design and even write programs for certain problems.
Yes.
How did all that kind of happen?
So all that happened more or less in the similar manner. My job involved writing programs for analyzing data. There was a lot of data collected through various equipment. Okay, so they were more in terms of astronomical data. So we did a lot of analysis. A lot of programs I wrote initially was in Pascal and Fortran. They were to do with the algorithms and other things required to analyze the data. There was a book called Numerical Methods. I still remember that, which was essentially a collection of algorithms in Fortran and Pascal. In those days, it used to come in those languages. Later, I had seen that book coming in the C languages as well. So we had to implement some of these algorithms, and testing those was a bigger challenge because you need to understand the science behind it, the application of these algorithms into the space that we were using. So we had inventive ways of actually testing some of these programs. I would say that I learned the logic part easily enough. I didn't find that a big challenge, right? Once I started trying out things, I got the hang of it. So that is how it all started. And I would say that this experience, right, it helped in being self-reliant in many ways. So even now, this thing of finding solutions, going, looking, doing the research, finding solutions, that is something that has never left me after all these years.
That's nice. That's nice. In fact, I was wondering, today you have so many test harnesses. At least when I started my career, I know that J units came up, and then it was relatively sort of easier to test a program. At least you could, we had enough of scripting languages by then, and test harnesses that, offered you some means of writing tests, automating them, providing, you could provide data sets from anywhere and so on. So I was just wondering, when you were speaking, how you would have actually had to build everything from scratch.
Yes, we did have to build everything from scratch. And the testing for scientific applications were very, very different. So for example, I have to test a software which I have written for Fourier transform, say, right? I do know that you cannot always predict the output, right?
Yes.
So you have to look at the output. I will give you an example. I wrote programs for finding out structures of crystals. So basically what happens is that the data for that is that they pass light through a crystal, right? And what you get on the other side is the Fourier transform, and you have lost the phase information. So you get only the amplitude information. You don't get the phase information. So the whole program was about reconstructing the phase information. And we did that by a method which was called maximum entropy method. That was about searching the n-dimensional space for a local maxima and seeing whether that fits in with what we know about that particular crystal. Okay, that crystal could be a normal crystal or a protein crystal or whatever it is. The way we would test that is very different from the way we test software, a commercial software, for example. These are sometimes simpler, and in physics, especially in types of problem statement like this, we need to give specific inputs and see whether, those kind of outputs are what we are getting. And to determine what those specific inputs could be, you need to understand the science behind it, right? What happens, when we take a Fourier transform of a known crystal, for example, right? Or a simple crystal. Or if I just try to get a Fourier transform of a certain type of wave, what is the output which I am expecting? Am I getting it, right? If not, I know that my program has gone wrong somewhere. So actually finding out whether you have done the right thing, that sometimes is a challenge. And optimizing some of these algorithms is even more of a challenge.
Wow. While it sounds simple at probably atomic levels, when you put it all together, I'm sure it must have had varying degrees of complexity. But at the same time, I found your example very fascinating and very interesting, Usha. After that, what did you do? Where did you go after Raman Institute?
Okay. I spent nearly a decade or more in Raman Institute. So after that, I joined this company called I2 Technologies. They were into supply chain planning area predominantly. They had products in that area. So they had something called demand planner, demand analyzer, and so on. So that later, I think the products must have got renamed and must have gone through many evolutions now. But that was one of the areas which I worked in next.
And what did you do there? Were you in a development role or in a management role? What
No,
was your
no.
role like?
Interestingly, that was the first company where I got involved in terms of functionality, in terms of testing, in terms of performance testing, and so on. In fact, I set up the first performance testing lab for I2. I would say that my strengths were in pioneering things, doing things for the first time, doing research for that, and getting things started.
That must have
So,
been quite a challenging thing to do in a company where, there are business objectives. Notably, you have to sell or you have to make a profit out of something. So
yes,
how was that environment like?
I would say that it was very interesting. I liked it. See, it is very different from a research organization. In a research organization, you are not so much pressured for time. Yes, there are time pressures, but not all the time, right? But I would say that this transition was gentle because it was a company which sold products. I learned a lot of things, I would say not intentionally, but by just being in that environment, listening to people, I learned how people sold software products, right? Even in those days, IT used to sell their demand planner and demand analyzer. The pricing they would put or they would charge the customer was based on how much ROI they get out of this product, so to speak, right? That itself was a very interesting concept for me because this was way back in the 90s. I've never heard of people doing things like that, taking responsibility for what they sell in this manner. So that was an eye opener, and it was really very nice. And the product itself used a lot of statistical methods internally in terms of optimization. At that time, I was introduced to a book by Goldratt. It was called The Goal.
Mm-hmm.
It was about identifying bottlenecks in the process and how you remove the bottlenecks to make sure for a easeful process flow. So it talked about how you would reduce inventories and things like that. And those principles were really applied in terms of supply chain planning, actually. So those concepts were very interesting for me.
Wow, this is actually the first time I'm hearing somebody reference Eliyahu Goldratt's very classical book, and the fact that you actually applied it in the course of your work.
It was applied in the product. See, we do apply it in lean, right? When we
Yes.
talk about lean, we also talk about removing the bottlenecks and, make sure that your work stack is optimal. So you don't want to clog the pipe, so to speak.
Yes. So when you said you actually set up and conceptualized and set up a performance lab, and those days there was no virtualization to speak of, and you actually had to have multiple physical machines or maybe configure enough resources onto machine for you to actually characterize the performance of a product. What was that like?
I would say that again, it was a new thing. So to that extent, it was very interesting, I would say. So we used, of course, Load Runner as a tool was there. It was the initial versions of that tool, which was there. We had not yet invested in it, so to speak, but we did have an evaluation version of it initially. And we used all the monitors available on the Windows systems. So we learned how to use performance monitors on Windows to get some of the parameters that we need, for instance, right? Without actually investing in that tool, because this was a product. And for the first time, we were thinking of testing the performance of that product, right? Computer power has grown exponentially since then. And at that time, we had limited resources, both in terms of memory and other things, which was accessible to us for doing these kind of experiments.
Yes, I'm sure it must have been a really constrained environment, and all the while you're watching for how much you're consuming, how much can I do with what I have. Yes. Versus, I think that's a problem that not many people are even aware of today. Today, if I just want, I'll make a request for an instance of what I want, and I'll just launch my whole environment on it, write my code, and then just push it through another set of pipelines. It'll, get pushed into deployment, and I can, at the drop of a hat, spin up as many test environments as I want. And it's so simple now, it seems.
Yeah, it is considerably simpler. I remember a time we used to write code where we need to use the existing memory very carefully. So we had to swap out some things, put some other parts of the code into the memory for that period of time, right? Some things which we take for granted now, the operating systems actually do that for you now. But in older days, some of these things you had to take care of yourself in your programming, right? Then we moved on to parallel computing with transputers and things like that. And they had their own language, and then you were working with things like that. But now you have processors with so many cores and whatnots, which does similar things. Yeah, we have come a long way since then.
Yes. No, in fact, I wonder very often, you are probably, one of few people today who has actually worked on a lot of things from scratch. Because when I meet a lot of students who are either fresh graduates or coming into the workplace, these things are just so unknown to them. If if you were to say that I need you to design this program and here are the constraints given, saying that you have limited memory. Now we'll probably have to define constraints to make people aware of what those kind of challenges are.
Yeah, but on the other hand, the challenges kids face today are very different from what we faced in those days.
That's true. I mean, at least for one, the sheer sources from where you're getting data, the types of data that are coming in, I think are providing enough challenges to people on the ground today.
Absolutely. So the challenges are different.
Yeah. So after, what else did you do in I2, Usha?
I2 was predominantly this, the supply chain planning, testing related to that and so on. So I learned things beyond testing there. So that was my first exposure to the industry. Different set of people, different ways of working, right? Very different from the environment at a research institute. One of the learnings was to ask the person sitting next to you if you had any challenges, whether they have a solution or not, rather than trying to do everything from the scratch yourself. That was a little shift because there was this tendency to go explore, find out, do by yourself.
Yeah, and I'm sure the timelines must have been far more stringent because you have a commitment to deliver.
Yes, you have a commitment to deliver. I mean, strangely enough, I was not very much intimidated by that. It was doable, and I did it. So I didn't see many challenges there in terms of the time I had to deliver. I mean, if I had moved to a services sector, it may have been a little bit more stressful, possibly, because you had a customer breathing down your neck and things like that. This was all internal. The planning was reasonable. And I don't think we had too many challenges in terms of less time or that sort of thing. Occasionally it happened, but it was not like every day. Work-life balance was good. So
that's nice. And thereafter, after I2, what did you do, Usha?
So after I2, I worked for a while in Siemens in Australia. So we had moved to Australia at that time. And I worked for Siemens for those 3 years and in the telecom domain. So this was again in the quality and testing area. So plus system integration. So those were the kind of work I did in Siemens. Yeah, the testing part of it was in the telecom domain. The system integration part of it was in the portfolio management area.
I see. So at any point in time, what are the kind of roles that you transitioned to? Were you always in the role of a developer, or what are the different kind of roles that you've played in various organizations that you worked with?
Okay, so I started with system admin. right? I have done a lot of system administration for both Unix and Windows. Then I did development, real-time programming with microprocessors, scientific programming, that sort of thing, system integration kind of work, and a lot of things in the testing area, predominantly in the testing area later on.
With your extensive background in testing and, today with the whole agile methodology of working, everyone says that everyone should know everything. I mean, if you are a developer, then you're also responsible for testing your own code. What are your thoughts on that? And looking at, a specialized testing role and function, how is that evolved? And, what does it look like today?
Okay, to answer this question, I think in early times when I started my career in testing, there was a lot of emphasis in independent verification and validation, as we used to call it. It is like, you tell, it's not that developers should not test their code, but the idea was that the completed code, there needs to be an independent way of validating it to ensure that it meets the business requirements. So that was the kind of thing people believed, right? We all believed that, saying that that is where testers can provide value, right? And a lot of things evolved around that in terms of independent verification and validation. Then there was this domain angle where you expected the people to understand the domain so that they can do IV and V better, right? So we went through those modes of working. And then now we have come back to the thing that from an agile perspective, that quality is everybody's responsibility. It is not just like a gate anymore, where you say that you give a go, no go decision. So the responsibility of actually delivering the software lies with the team nowadays. And that is the expectation, that there is collective responsibility towards the project goals, project or product goals, if you will. That is a shift I have seen. We are continuously evolving. This shift is good because when it becomes a collective responsibility, you know that you need to work together and deliver this.
Yes, I also recall that this used to be a very siloed mode of operation, and very often there would be tensions between test and development teams. And typically when it came to product release, or if you did the, let's say, a root cause analysis session afterwards, you'd often find teams trading blame, saying that, oh, we didn't receive the code on time. Oh, we found it really buggy. And then came in the concepts of shift left and how can you find things early on. So in some sense, I think a lot of it was lending itself to a collective team responsibility and working a lot more closer and together. Right?
Yeah. Interestingly, what we call shift left has been there from the 80s.
Yes.
So I would say that the way the whole software development lifecycle was organized, it didn't lend itself well to implement these practices, right? We always did an RCA, right? Even in the 80s and 90s, people did root cause analysis, and they would say that, okay, this defect was introduced in this case, etc., etc.
Yeah.
Right? But it all depends on how strong the concept of quality was within that organization. Whether they embrace that culture. See, a lot of people, a lot of organizations get certified on CMM and ISO and so on, right? But the actual practice is a little different from what is mandated by these frameworks sometimes.
Yes.
And there are many reasons for that. You can't really, blame the people, right? There are a lot of pressures which teams undergo.
Yes.
However, I think in an ideal world, right, quality should be everybody's responsibility. It should be a collective goal, but getting people aligned to that goal, I think that is where the difficulty is even today. Right?
Yes, having a shared common vision, it's much easier said than done.
Yes.
Yeah. So in your role as a consultant or a coach, what have you used as some of the techniques to get teams to sort of see the same big picture and see the same end goal?
This is again an interesting question, partly because when we do talk with your customers and you talk to a particular team, say a particular Scrum team, you speak to them, even though they are part of a larger program or a larger Scrum team, they are sometimes so focused on what they can do and what they cannot do. A lot of times we have actually seen that the understanding of definition of done is different when you take at a program level and at a team level. So it is very different. So making people aware of what is expected and where they are tying into, what is beyond what they are doing, how what they are doing ties up with the bigger picture, I have found that that helps.
So with the current scenario in the entire CI/CD space, and especially with containerization and microservices, there's a plethora of tools, frameworks going all around. And people sometimes either over-engineer or they get so overwhelmed by it that they struggle to actually put something together. What have been some of your observations, and perhaps what would be some solutions that you could provide?
I am not an expert in the CI/CD tools and tool integration, Chitra. See, I have looked at this thing predominantly from the testing perspective, right? And what we have done is quite a lot of testing frameworks and automation frameworks. And we have looked at ways of integrating these frameworks in the CI/CD mode, right? How to make sure that, for example, test cases are kicked off, not just kicked off automatically, that they can, for example, run in a batch mode without false failures. So those are the kind of things that we have predominantly looked at. I have really not looked at the entire life cycle of CI/CD tools. Yes, there are many out there, but you have to pick up something which suits your organization and your customer. Quite often, a lot of these things are mandated by the customer, and then you would use it. You may not really have a choice in what you use them. I would say that as long as your setup gives you the ROI that you desire, or you are going towards it, you are going towards getting that ROI that you are expecting, then I would say that the solution is right for you.
Okay, so you mentioned ROI several times in this conversation, right from your experience at I2.
Yeah.
And it seems to be very much part of you. And today we do, as coaches or trainers or whatever we do, it's a good practice to steer people towards being mindful about what they are measuring. Okay, so that you know where you're headed, whether you're headed in the right direction or not.
Yes.
So what in your experience have been good measures of ROI, and what is it that you would teach people in terms of how to first define those and what they should be?
So when we look at testing and testing automation, right? Test automation, we define return on investment by, for example, capital expenditure we have on the tool, plus the costs due to the effort we put in to develop those tests, right? And we estimate the returns by looking at how much time, for example, we have saved with each run.
Okay.
Right? Are we able to do more by investing less? Right? Investment in terms of people, time, etc. So if this works to our advantage, for example, we would see reduced cycle times from an execution perspective. That's one of the typical things we look at. So whatever used to take over 3 days, you may do it overnight and it is done for you to come and look, review the results and move on, right? So if that happens, we would say that we have got a good ROI, right? If we talk about ROI in terms of development itself, Agile itself incorporates it in terms of business value, right? We tag stories with business value. Yes. And then that is how you measure, how much business value have I delivered, versus what I was doing before. I would say that depending on the situation, the ROI should be defined. It's not universal in every situation, but it is
Yes.
context dependent, and you do make a definition based on that.
Yep.
Based on what is important to you, your customer, your employer at that point in time.
So, Usha, in your experience, have you actively interacted with end users? How have those interactions been? What have your learnings from there been, and how have you kind of brought that back into the work environment?
I can say in a couple of scenarios, I have really worked with the end users, right? So I was talking to you about doing system integration, right? Where we were developing code and the customer was sitting in the same room as us, right? We were actually doing it there, and it was in the financial sector. This was not portfolio management, but something similar to that. This was about home loan processes and things like that. And we were developing software. I was actually developing software using off-the-shelf product, right? And the customer was there in the same room as us, and they were doing user acceptance testing. Right?
Okay.
We would develop, drop the code, integrate and drop the code every day. And they used to test it every day. This was pre-agile days. Had a first-hand view of how they look at that process, how they look at the business processes and how they use it. It is, even though I came from a testing background, there were certain things, obviously, that you learn that however much you say that you have achieved the desired coverage, it still may not be the way the end customer is looking at it. So they do find bugs, and then we would fix them on the fly. So that was a really good experience, and it actually honed my testing abilities even further, right? To look, what are the things I should really look at? What would the customer view this as? Because they are experts in the business process, right? While we see the documented part of the business process, we do not know so much about the unstated requirements all the time, because even though you may understand the domain, it may still be something new to you. You are not at that level of expertise to talk about at the completeness in terms of the features and functionality you actually should have developed. What did the customer really want?
I was just thinking that what we use some tools today, we call it ethnographic research, but it's basically looking at a day in the life of that user, isn't it?
Absolutely. And that really helps. See, you learn as you go on, for sure, because if you make a mistake, right, it will turn up in the next stage, right? And you will spend time and money in fixing those problems. You learn from that too. That feedback loop also happens. You do that too. But nowadays, I think with Agile, we are trying to preempt it by being constantly in touch with the customer, asking them, is this what you really want? The way, for example, a user story is articulated, it is about a slice of time in the day of that user, what they do, what they are likely to do. So that really helps in terms of articulation, in terms of shared understanding as to what is it that we are looking at. I really find the idea of acceptance criteria very good, because by documenting it like that, it is very clear to everybody how this has to be developed, how this will be tested. The rigor of testing also will come through in those requirements themselves, and that certainly helps.
Definitely.
So better the articulation, better the defect prevention, so to speak.
Yeah, and I think it's a continuous refinement process, right? With every iteration, you just get better with articulating very solid acceptance criteria. And I love the fact you said shared understanding. And in my experience, once the shared understanding grows, it also organically gets that much better. Of course, provided that the team is kind of tuned into each other, as well as the fact that we're all working towards a common purpose.
I agree with you there. In fact, I was about to talk about, the team dynamics themselves, right? How critical it is for the success or failure of whatever they do as a team.
Oh, yes.
Right.
Yeah.
So it is important to build the right team. Especially in Scrum teams, there are 6-7 people who are working together day in and day out. They better get along with each other.
We have had a very interesting conversation for the last 45 minutes. And usually before we close the podcast, we invite our guests to share what has really worked for them, as if you were to give advice to people considering a career in software, technology, or engineering. What would be some of your words of wisdom to aspirants?
It is important to follow your heart and follow your passion. If technology and software is not your passion, please do not go for it. Okay. And if it is your passion, go for it and, give your 200% to it. Whatever that area might be within technology and software, there are so many areas, right? You do not know whether you would like something or not like something, but you make sure that you are following your passion. If your heart is not in it, it is very difficult to do well in that area, unless you are a very exceptional person to start liking something you didn't.
Simple enough, Usha. but very hard for people to find and practice.
No, I find this especially important nowadays, because there are a lot of people that you see who really do not have an interest. They get in for various reasons and then they struggle and then they drop out. Yes. I think sometimes it's such a sad thing to see. There are so many things. I mean, I would say that the world has opened up. There are so many opportunities nowadays about so many things. So one should not get stuck up. It's okay. If you make a mistake, you should realize it quickly and move on. So
yes. And perhaps treat every experience like an experiment. Okay, maybe I don't know too much about this, but hey, let me go and give it a try. If it works, fine. If I find out that I like it, I'll go with it. Otherwise, I'll move on to something else.
You learn from every experience, even though you think you don't. This has been a big learning for me. There are times in my life where I felt I have learned nothing over these last few years. But then when you sit back and contemplate, that is not true, right? Everything you went through has enriched your life in some way or the other. In terms of knowledge, in terms of things that you learned, right? The way you think differently now from what you used to think, how you have fine-tuned your abilities. So
even I share this with anybody who asks me the question. I said, every day there is actually something to learn.
Yes.
So Usha, thank you so much. This has been an enriching conversation at many levels. I know we explored, probably touched tips of the surfaces of many topics, but that's usually what a conversation like this would be like. Maybe there's potential for a lot more podcasts, and we could always talk about that later. But thank you so much for your time. This was a really nice conversation.
Thank you, Chitra. It was interesting for me as well. And it was a new experience, right? I had not thought about some of these things for a long time. You made me think.
Okay.
That was
Thanks,
nice.
Usha. Thank you.
Thank you.
We thank Siddharth for the music and Anita for promoting the Software People Stories.
If you like this episode,
Please subscribe on your favorite podcast client.
And spread the word in your network.
if you'd like to share your story,
Contact us at podcasts@pm-powerconsulting.com.